Hi everybody. Today we're talking about dictionaries and what they are and what they can be used for. And dictionaries, they are a kind of data structure in Python that consists of two key elements. One is the key, no pun intended, and the other is value. So Control Enter to run that cell. And these dictionaries, they are incredibly efficient of storing these key value pairs. And the way that we use them or create them is by providing this comma separated list of keys and values. In this case, we're looking at the days of the week, and we are providing the temperature for each day in this dictionary. So what you have noticed is that we have these curly brackets at the start and the end, and these define this data structure as a dictionary. So Control Z to get that back. And what we have here is that we have the key, which is often, but not always, a string, a colon, and the value. So the key and the value. And each key value pair is separated by a comma. And what you can do is that you can actually have all these key value pairs in the same or on the same line if you choose to do so. So if we just remove the line shift here, we can actually define this dictionary on one line. However, it's more practical to actually define the dictionary as such, because then you have a column of the keys and a column of the respective values. So if we run this cell by Control Enter, and then we define the dictionary, and we can check here the type of this data structure. So if we run this and we see that what we have made here, the temps dictionary, is actually a dictionary. So it's a data class, which is dictionary. You can get the length of this dictionary by running len temps dict. So we have our dictionary, and we see here the number of key value pairs in our dictionary. In our case, we have 7 key value pairs because we have 7 days in the week. We could also print what's inside of our dictionary variable, and then we would get Sunday value, Monday value, and so on. If you need to get the value of a certain key value pair, then you can just print the dictionary name and the key. And then you would get the value for that key. In our case, we would like to have the temperature for Monday, which is here, which is 70.2, and indeed we got 70.2. So you have the dictionary name and the dictionary key in square brackets, and you get the corresponding value. And these dictionaries, they can be of any data type. So for example, here we have a string and string variable or dictionary. So the key is a string, but also the value is a string. So here we have the snow dictionary, which tells us whether or not a given day in the week had snow. Okay, so we have Sunday, which had snow. Monday also had snow, but none of the other days had snow. And if you would like to know if Saturday was a snowy day, then you can just call the snow dictionary name, and within these curly brackets, or no, within these square brackets, you could define or give or provide the corresponding key, in this case SAT for Saturday. And what we see here is that we should get no snow. So if we run this, Control Enter, we get no snow. You can also have a numeric key and a string value. So the key value pair is numeric string. And down here we have that. We have the winner's dictionary. And at place number 1, we have Maria. Place number 2, we have Peter. And place number 3, we have Ali. And often we define our dictionary as such with each key value pair on separate lines. And then we would like to, after defining this winner's dictionary within these curly brackets, and remember these colons which separate the key and the value, and then we would like to print the first place goes to, and we would need a call for the value for first place, which we get by calling the winner's dictionary, and within square brackets we have the key value, in our case 1. If we run this, we see that first place goes to Maria. We can also have a numeric key and a list value. So in case we have, for example, groups, we can make a dictionary of the groups, which we call groups dictionary, and we have the group numbers as key values and separated by colon. Within these square brackets, which makes this a list of names, we have our group members. So in this case, we have group number as a variable because we have 3 groups, and we would like to print the members in the group. So then we call the print function, and we provide the first part of the string, members in group, and then we provide the group number, and we use the format function to make this number into a string so we can print it along with other strings. We have a string here with some blank spaces and a colon, and the most important part here is the group numbers. So this is the groups dictionary and group number. So for example, for group number 3, we have members John, Chang, and Lars. However, if you have a list of names or values as the value in the key value pair, then you can actually drill down and get more specific information. And what we're doing here is that we would like to find the third member in the group, which is defined as Lars, and we are printing the third member in the group is, and we provide the third element in the value list here. So just be careful, because you have the dictionary name here. You have to provide the key value to know which key value pair you are looking at, but this returns a list. As we saw here, the group's dictionary group number, which was 3, returned a list of John, Chang, and Lars. We saw that here. And if we would like to get the third element of that list, then we have to provide the corresponding index for this third element. And we do that with a square bracket outside or after the dictionary name and the key value. So remember that John is at place 0, Chang is at place 1, and Lars is at place 2. So in our case, we should get Lars. So the third member in the group is Lars. We could also have a tuple as our key value and a numeric value. So we have a tuple numeric key value pair. In case we have dates as key values, we can make a date dictionary where we can look up which day falls on which date. So if we are given the date, then we get to know which day of the week that date corresponds to. So if we define this dictionary, then we can get, for example, the weekday for date February 8, 2021. So if we print that and we see that this was a Monday, and this key value we find here, and the value corresponding to that key is indeed Monday. Some of you might now say that, well, isn't this just a list? Well, it looks like a list, but it's not ordered. So this information we have here is not ordered, which means that we cannot access this information by indexing. So if we try to, for example, access the first element in this dictionary, then we get an error message. So we cannot access the information in a dictionary by indexing. And another point is that it is not illegal to call your dictionary for dictionary, but you should not do that because dictionary can be confusing. You should rather call your dictionary something which tells the user about what the dictionary actually stores. But what are the benefits of using dictionaries versus using lists? As we say here, the dictionaries are a good alternative to lists when we would like to associate each item with an identifier, which is the key. So think about the key, and if the key is a username, we would like to associate that username with only one password. So we would not like for that username to be associated with several passwords, for example. So then we have a one-to-one relationship because you do not want to associate a password with several usernames either. So in our example here, we would like to store the daily mean temperatures for a week and create a program that asks the user for a day and then display the temperature for that day. Okay, so without using dictionaries, how would we go about it? We would make a list and we would call this daily temperatures, and in these square brackets we would have the mean temperatures for each day of the week. So these temperatures are in Fahrenheit, and we can print these daily temperatures, and we can see that yes, it's a list of 7 floating point values here. So, or decimal numbers. So now we would like to ask the user for a day of the week and give the resulting or the corresponding temperature to that user. So we're asking the user for an input here, and we're writing enter Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. And just notice that we are using double quotes here because we have single quotes in our text. And this input is a string variable which we put in this box, this string variable called day. And depending on which day the user have entered, we are going to look for the corresponding temperature in the daily temperature list up here, which we have defined. So if day is strictly equal to Sunday, then the temperature variable should be set equal to the value in the daily temperatures list at index number 0. So Sunday is at the first place here. And then we just continue the else if statement and checking whether or not the inputted day name is equal to any of these tests. And then we would like for the program to print out the average temperature was, and the format or the temperature has to be a string, so we use the format function for that, and we add degree. Or we could actually just take degrees here. So if we run this, we are prompted to enter either Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. So I like Fridays, so we entered Friday, and the average temperature was 75.6 degrees. And Friday is the penultimate day in our list here, so yes, it is 75.6 degrees. However, if we use a dictionary, then we can get by with a lot less code. So here we have daily temperatures as a list. You see that with the curly brackets here, and every single key value pair is separated by a colon. In this case, the key is a string and the value is a number, and each key value pair is separated by a comma. So we can just generate this dictionary of key value pairs and print it. So now we have stored this dictionary in this dictionary variable called daily temperatures. So we can ask the user for a day of the week, and the temperature will be equal to the value in daily temperature, the dictionary, corresponding to the day of the week, or the string, which the user have inputted and is stored in the day variable. So, and then we would like to just print the corresponding temperature. So we have the print statement, and we have one piece of string here with a number which should be placed within these curly brackets with the format function. So if we run this, we enter Sunday, and we get the average temperature was 68.8 degrees. Up here, we have entered the key value pairs while defining this daily temperatures as a dictionary variable. But we can actually make a dictionary variable which is empty. So if we do that, we just name the dictionary variable and set it to an empty dictionary. So if we do this, Control Enter, and we see that we are printing the type of the contacts variable, and this contacts variable is actually a dictionary class variable. So then we could add items one by one, and we are not using the append function for lists, but here you can just define the name of the dictionary, and you can provide the key value that you would like to add, and you just set that equal to the value. So here you just provide the name of the dictionary, the key value, and the value in the value pair. So if we run this, we can see that contacts, well, it's empty for now, but we would like to add these 4 contacts, and then we would like to print the length of the contacts dictionary variable, which should be 4, and then we would like to print the content of the contacts dictionary variable. So if we run this, we see that yes, we have added these 4 contacts to the contacts dictionary, and the length of the contacts dictionary is 4, and the content in the contacts dictionary is Fred, Mary, Bob, and Sarah. We can also, as we did above, add items when the dictionary itself is created. So if we know what kind of information should be in this dictionary variable, for example, we have been provided with a text file with contacts, then we could read in the contacts text file and put the information in a dictionary variable, which we call, for example, contacts. So we can actually define and populate the dictionary at the same time. And we can also test whether or not a specific key is present. So for example, if we put the string John into this name variable, so we have a string variable called name, and the string contents in that string variable is John. So right now our contacts dictionary contains Fred, Mary, Bob, and Sarah, and we're testing whether or not John in contacts. So John in contacts, well, that's false because we do not have a John in our contacts dictionary. For example, we could test whether or not a key value is in the dictionary, and if it is in the dictionary, so if name in contacts is true, then we could put the name, or the value, I mean, in number, and we could print the name and the number of the contact. But if the name is not in contacts, which is the key value is not in the dictionary, then we would print the name is not in contact. So for example, in our case, we put Mary in the name variable. So if Mary in contacts and Mary is in our contacts dictionary as a key value, then we run this piece of code because this is true. So then we put contacts name, so contacts Mary, because name contains Mary here. So when you write the name of the dictionary and the key value, then you get the value of, or corresponding to, that key value. So we are looking for this number, which is Mary's number. And then we can print the name is, and here we are formatting the name, and we are also adding a new line here and the phone number as a string. So here we are turning the number, which came from contact's name, into a string. So if we run this, we have name is Mary and phone number is 38 and something. But if we have Bill here, well, Bill should not be a key value in contacts. So name in contacts, if Bill in contacts, well, that's false. So we run the else portion of the if sentence. So then we have name is not in contacts, which is Bill is not in contacts. So if we just turn that back and get to the next point, which is that dictionaries are mutable. So we know from beforehand, or as we have seen, that we can change the information in a dictionary. So, for example, values can be updated by assigning new values. So we add a contact because John is not in contact. So we run this, and it's quite easy to add a new key value pair. You just define which dictionary to add the information to. You provide the key value and you provide the value. So the dictionary name, key, and value. So now we see that yes, we have Fred, Mary, Bob, Sarah, and now also John in our dictionary. But what if we realize that John's number is totally wrong? We need to update this number. Well, that's quite easy, because then you can just provide the dictionary name, the key, and a new value. So if we do that and print the contents of the contacts dictionary, we have Fred, Mary, Bob, Sarah, and John now has a new value corresponding to the name. And you can remove any key value pairs using the pop function. So if we run contacts.pop function and we provide the key of the key value pair we want to remove, then we can just print contact, and we see that yes, Fred has been popped out of the dictionary, and we are left with Mary, Bob, Sarah, and John. But if the key that we provide in this pop function is not present, we are trying to remove some information which is not there, then we get an error message. So Sue is not a member or a key value or a key in this dictionary, which means that we cannot remove that contact. Because of this, it's a good idea to use the membership operator to avoid any errors. So here we have an if statement or an if sentence, and if Sue in contacts, so if this is true, then run this piece of code. And then we should print then we should print the contacts. Okay. So if Sue in contacts, then pop Sue, and then print contacts when you're done with the if statement. But Sue was not a member in the dictionary, so we did not run this piece of code. If we had said Mary, then we could run this, and we see that Mary has been popped out of the dictionary. We can also iterate over the items in a dictionary using a for loop. And for example, we can print my contacts on one line, and then for each key in contacts, print key. So if we run this, my contacts, they are Bob, Sarah, and John. Yeah, because we popped Mary out of our contacts list. And we can call this key variable whatever we want to call it. So we could, for example, call it key values, and we would get the same result. But for now, we just call it key because it iterates through the keys or the key values in contacts and prints out the key. And we can also print the contacts in alphabetical order using the sorted function. So we can define our contact list again here, and for each key in sorted contacts, then print the key, and we print a colon with some empty spaces, and we print the value corresponding to the key. So this for loop will run through the sorted contacts. They are sorted based on the key values, and it will store each key, like Fred, Mary, Bob, and Sarah, in the key variable one at the time, and then print the key value and the contacts dictionary value corresponding to the key value. So here you would have Fred, Mary, Bob, or Sarah. This piece of formatting just indicates that the key value should be printed in a space of 10 characters, which means that the colon is aligned on top of each other. So here, Bob is printed over 10 characters, and then you have the colon and the space before you you get the value corresponding to the key. But the format function turns this value into a string, which we have to do to print it out. Alternatively, we could use the items function to return a sequence of the tuples that contains the key and value pairs of all the items. Or you can, for example, loop through each key value pair in contact.items. So here the dictionary data variable has a function called items, which gives us the key value pair. So here we have Fred, we have Mary, we have Bob, and we have Sarah, corresponding with their values.